Hey y'all, in this video we are going to go over the example from the part 2 notes, and this is where a projectile is launched at an angle. So in this one we have a cannonball being fired from the ground at 100 meters per second at an angle of 30 degrees above the ground. So first off, let's just draw a picture of what's going on here just to give you a visual. And so we're launched from the ground here, and we're going to land over here also on the ground. So the launch and land at the same height. The initial velocity here going up at this angle is 100 meters per second. And this angle to the ground is 30 degrees. So the first thing we're going to want to do with these types of problems that are launched at an angle is break down this initial velocity into how much of it is going horizontally and how much is going vertically. So this is a vector problem essentially. So there's some of that velocity that's causing it to go over. This would be our initial horizontal velocity. And then some of it that's causing it to rise into the air, that would be our initial vertical velocity. So the formulas we're going to do this are just sine and cosine. So technically, this VIX, that's your adjacent side to this 30 degrees. So it's going to be your initial velocity times cosine of your angle. So it'd be 100 cosine 30 degrees. And that is going to equal 86.6 meters per second. Right? And then for VIY, it's going to be similar, but just with sine. So it's going to be your initial velocity sine theta, because VI here is opposite of our 30 degrees. So it's going to be 100 sine 30, and that is going to equal 50 meters per second. So that's our initial velocity. So we're going to add those into the chart we have here. So we're going to have 86.6 and 50 in the y column. And we're going to go ahead and plug in our accelerations. Unless we're told otherwise, our horizontal acceleration is 0 meters per second squared, and then negative 9.8 meters per second squared for the vertical. And again, those are always going to be that unless you're told otherwise. So now getting to our actual questions, we can see first question here says, how long is the cannonball in the air for? So we're looking for time. There's two ways you can do this. I'm going to show you one now, and then I'm going to go at the end of the video, I'll show you the other way. And you can pick which one you like. The other way I'm going to show you is going to come up again in the next set of notes in a very similar way. So you may just want to stick with that way instead of doing, this way for this and that way for that one. So the first way I'm going to show you, to me, this is an easier way to do it, but you can decide for yourself which you like best. So what we're going to do here to find time in this method is find the time to the top of the parabola. So here we're looking for it right here at the top, and we're going to find the time to the top, because at the top, our final velocity in the vertical, if we set this as the endpoint, would be 0 meters per second. This is just like when we went back to vertical motion of throwing something straight in the air. It's the same deal here. So it'd be 0 equals our initial vertical velocity of 50 plus negative 9.8 times time. And then we just want to solve for time. So we'd move the 50 over. That equals negative 9.8 times time, and then divide both sides by negative 9.8. And we get a time to the top as 5.1 seconds. So I'm going to just put top to remind you that's your top. We don't want just the top, though. We want the whole way. And since this is being launched and lands at the same level, this time to the top is going to be the same amount of time to the bottom. So you're just going to have to double what you find. So we're going to multiply it by 2, and we get 10.2 seconds total. And that's the answer we actually want for this question. But keep that 5.1 in your mind, because we're going to use it in a couple questions. All right. So moving on to question 2, we want to know how far the cannonball travels horizontally. So we're looking for horizontal distance. So of course you're going to use your distance formula, and you're going to use the horizontal information. So your horizontal distance is equal to your initial horizontal velocity times time, plus 1/2 times your acceleration in the horizontal times time squared. So we're solving for distance, so we're going to leave that alone. Plug in the VIX we found earlier, which was 86.6 times our time. Now, we had two times. We had the time to the top and the full time here. This full time is what we want to work with. So really I need to add that to my chart over here. My full time to the top is 10.2. And then the second half of this I can just go ahead and get rid of, because that acceleration is 0. So we're just going to multiply 86.6 times 10.2, and that's going to equal 883.3 meters. So this cannonball flew quite far, unrealistically far. All right, so now let's move on to the last question here. We want to find the maximum height. So height is also a distance. Now we're just looking for the vertical height. So we're going to use the same formula, but with the vertical information. So it's going to be the initial vertical velocity times time, plus 1/2 times our vertical acceleration times time squared. So this is a similar process. You're going to just plug in 50 now for your initial vertical velocity times time. Now, would you want to use your full time or your half time? So your full time is this 10.2 up here. This half time, very top of my screen, is 5.1. Which one, where is it hitting its max height at? Is it hitting it at the end at 10.2 seconds after its travel, or is it hitting it in the middle at 5.1 seconds? I hope you're thinking 5.1 seconds, because that's what we want to use here, because it took it 5.1 seconds to reach the top. So that's what we're going to plug in to solve for the maximum height that it reaches. And then we're going to add 1/2 here times negative 9.8 times 5.1 squared, right? And then when we work all of that out, this first section is going to equal 255. The second half is going to equal negative 127.4. And then we add those together, we get 127.6 meters, or close to that. Depending on how you rounded throughout the way, as long as you're close to that, you're good. So that's it for the 3 questions. So if you're good, stop here. But I am going to go through now the alternative way to solve for time. So if you want to know how to do that, just keep watching. So the alternative way to solve for time is going to be to use the quadratic formula and the distance formula. So you're going to solve for the time using the distance formula, and you're going to use the vertical side of your chart to do this, because you know a little bit more information with the vertical column. So you have here our horizontal distance. In this case, technically it's displacement. This number here is going to be 0, because when we look back at our drawing here, it starts off the ground and it ends on the ground. So the total distance, the total displacement of this ball is going to be 0. So that's why we're going to plug in a 0 for this part here. So it's going to be 0 equals 50 times our time, times the time plus 1/2 times negative 9.8 times time squared. And then we're going to simplify this. So it's 0 equals 50 times time plus negative 4.9 times time squared. And now we're ultimately going to use Pythagorean theorem, quadratic formula. So we want to rearrange this just to make it easy to figure out what's A, B, and C. And all you're going to do is switch the places of stuff. So it's going to be 0 equals negative 4.9 t squared, because the one that's squared always goes first. And then we're going to add 50t. We're just swapping these. And then technically, it's not here, but quadratic formula, you need something on the end, and that would just be 0 technically, even though you don't really need it. So then this would be A, 50 would be B, and then 0, technically, it's not really there, would be C. So now we can plug things into the quadratic formula. Your quadratic formula is going to be time's going to be equal to negative b plus or minus square root b squared minus 4ac all over 2a. So now we can plug in our a, b, and c. So we're going to have negative 50 plus or minus the square root of 50 squared minus 4 times negative 4.9 times 0. And that's going to be divided by 2 times negative 4.9. So from here, we're just going to simplify this down. Let me move this over a little bit. And that's going to equal negative 50 plus or minus the square root. And this bottom part here, we have the 0 here. So this second half of this is going to be canceled out. And then 50 squared, when we put that in the calculator, we end up getting 2,500, and then divide that by negative 9.8. And then we can simplify this down even further and get negative 50 plus or minus, and the square root of 2,500 is 50. Really, you didn't even need to do that, because if you look, like when we have it here, 50 squared, and then you're square rooting, it's just going to be 50. So if you're good at math, you could have skipped that part. And then divided by negative 9.8. So now you have the plus and minus options. So you could have negative 50 plus 50 divided by negative 9.8. And that would equal 0 divided by negative 9.8. So that's going to be 0. And then you would have negative 50 minus 50 divided by negative 9.8. That'd be negative 100 divided by negative 9.8. And then that would equal 10.2. And this is your time, so it would be in seconds. And then that is your total time. So if we go way back up here to what we got in the beginning, we just got 10.2 and we found 10.2 up here. So you can see that they match. So you have the option of quadratic formula, or you have the option that we originally did here. You just have to remember to double it. Okay. Anyway, I hope you guys are good, but if you have any questions, just let me know.